today. 2101, donate the maximum bombs. Yeah, so we want to donate the maximum bombs, and the question is straightforward. So we have a position, so that is x, y, and r. So x, y is the coordinate in the Cartesian coordinate system, and r is the radius. So for this example, that is 2, 1, 3. So the radius is 3, the 2, 1 is here. So 6, 1, 4, it is here. Yeah. So this means in order to have the maximum donated bombs, we need to donate this blue one first, because after donate the blue one, and you can see the areas. So the radius areas go to this center of the circle. Yeah. So it means it's gonna have a maximum of 2. Yeah. If you donate the blue first, yeah, you see the radius didn't go through this blue dot in the center, so it means there's only one bomb donated. So yeah, we're gonna return the maximum. Yeah, and similarly for the second and third example, yeah, I'm gonna explain this question in the third example, because third example there's a lot of different cases. Yeah, but basically this is a DFS problem, and you need to know a little bit about basic mathematics. You need to know how to calculate the center. So for example, if we want to donate this pink one, if we donate from the center, so you need to know which bomb can be donated. Yeah, it means just the circle if it is inside the pink regions, so this bomb will be donated, and then those bombs will be donate others, and etc. It will be like this, so it will spread. But we want to calculate the maximum. Yeah, so this means for the DFS, we're gonna enumerate all the cases. It's like a brute force. We're gonna check what about if we donate 0 or 1 or 2, 3, 4. We're gonna try one by one until we get the maximum value. Yeah. Now let's just try to solve the problem. I solved this problem yesterday, and I think I can still solve it today. Normally, while I'm giving a tutorial, I should solve it immediately, and then I will give a tutorial, because yeah, basically I remembered all my code. But yeah, for this one, I solved it yesterday. Maybe after 24 hours, I may forget some of the details. But let's just start coding for this one. Yeah. So normally I'm gonna prepare a DFS. So inside of the DFS, I'm gonna starting from this I node. I will give a path first. Yeah. I want to prepare this adjacency list. Yeah, because of course this is not an adjacency list. We're gonna prepare an adjacency list. So J would be default dict, and inside it would be list. Yeah. Now we are going to prepare this adjacency list. So how can we prepare the adjacency list? Yeah, I mean this is just bombs for each one of them. Yeah. So yeah, for the adjacency list, we can prepare it one by one, I think. So for example, the first one, 1, 2, 3. Yeah, I think we're gonna need a brute force to prepare the adjacency list, because for the first bomb, for example, we're gonna compare with all others. If it is possible, we're gonna build an adjacency list, and also for others. For example, the bomb at index 1, it would compare with bomb 0 and all others. Yeah, because if bomb 0 can donate bomb 1, it doesn't mean bomb 1 can donate bomb 0. We have to compare all the cases. So this is why we're gonna prepare a length of the bombs. So we're gonna prepare the length of bombs. So for I in raise n, and for j in raise n, we need to check the cases if I not equal to j. Yeah, let me put something inside. So for the I can take x1, y1, and r1 should equal to bombs I. So this is for the I's bomb. I'm gonna take the coordinates and the radius, And similarly for bombs j, I also need to take it, so x2, y2, and r2 should be equal to bombs j. Now we are going to check if they are not equal. Yeah, we are going to check if they are not equal and can we build an adjacency list. So we're gonna check something like this. So for example, at this point, at this point we are going to check the distance. At this point we have a coordinate. For example, this is x1 and y1, and it has a radius of r1. We're gonna check all those dots, like the black or blue one, if it is inside the circle or not. If it is inside, we're gonna put it inside the adjacency list. So how can we do that? So this is like r1, the distance. So we're gonna check this point, the distance to this pink point, the distance of these two distance. So if the distance is just less than and equal to the square of r1, it means it is inside. We can build the adjacency list. Now let's try to build it. So the distance is like x. Let me use x2 minus x1 square plus y2 minus y1 square less than and equal to r square. So this means if it is inside x2 and y2, like this black dots, if it is inside, we're gonna build the adjacency list. This means 0 can go to 1, 0 can donate 1. So for the adjacency list, it would be gi. Because while building the graph, we only need the node. Because according to the node, we know if this 0 can donate node 1. We just use this information to build the adjacency list. This is the hard part of the problem. If you can solve it like this, normally you can solve the problem. So gi can append this j. Because j is another point. We're gonna check one by one. So after that, we've already built the adjacency list. Because we tried all the different cases. And for the next loop, for example, from index 1, it's gonna compare with all other indexes except itself, because here I have a I not equal to j check. After you build this adjacency list, now the problem becomes easier. It's just like a DFS traversal. You're gonna check the maximum value. Now let me prepare a result. Would be 0. So for I in range n, we're gonna try one by one. We're gonna check which one gonna be the biggest value. So since this part for the DFS, I will not have a return. So from here, I'm gonna run the DFS. So I'm gonna prepare a visited set. Let me check how can I do it. Let me prepare a visited set. Should include this node I, and I will execute the DFS with this node I. After executing, I have a length of the weighted set. It is the number of dots inside the weighted set. It is the number of bombs which can be donated. So the result would be the maximum of the result with the length of the weighted set. I'm gonna use the weighted set as my comparison of the maximum. After that, I'm gonna return the result. Now let's go to the DFS part. Actually, here should be easier. Let me put a x node. So for y in gx, if y not in weighted set, so the weighted set would add this y node and DFS y. So this, after running this DFS, I will put all the nodes which is connected, put inside the weighted set, and then I'm going to compare the length of the weighted set with my result. If it is bigger, I'm going to have the bigger result for this one. Now this is the entire code. Let me just have a check if there's anything wrong with it. Yeah, it seems here there's something wrong. Yeah, this is not R, it is R1 because I need to check this one. Yeah, the first one, it is R1. Now it seems everything's okay. Yeah, basically this is not so difficult, and also here this is not so difficult. So the difficult part maybe just about the mathematics formula. You have to prepare such kind of formula, and then you build the adjacency list. Yeah. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases. Now let's analyze the time complexity. Because the bomb's length is just 100. As you can see here, for building the adjacency list, this is just n square. And for the DFS, let's go to the DFS. Yeah, because for the DFS, actually this is a for loop, this is the ON time. And then we're gonna check the time complexity of the DFS. Yeah, normally after building the adjacency list, the DFS is E plus V, the number of edges and the number of vertices. But I think they didn't tell us the number of vertices. Maybe the number of, so the time complexity would be n, the number of vertices, times n plus this E, the number of edges. And the number of edges, for the maximum, it can be n times n. Yeah, so the final time complexity is n cubic. Yeah, so it should equal to n to the power of 3. This would be the time complexity. Because n is very small, it is 100. So that is why it can pass. And thank you for watching. See you next time.